Okay, I think I can start now. The homework is about clustering the data using Lloyd's algorithm, which is k-means clustering, which is known as k-means clustering. Okay. Lloyd's algorithm, as known as k-means clustering, is an iterative method for partitioning a dataset into k clusters. How we should cluster the data? Okay, how we should partition the data? First, we need to select initial centroids, which is k. As you can see over there, number of centers can be called set, or we just gave it here. Let's say we have 10 initial centroids and examine the dataset regarding to this. Assign each data point to the cluster with the nearest centroid based on Euclidean distance, which is here we are trying to do is here. And calculate the new centroids for each cluster by taking the mean of all the data points in the cluster. And repeating the steps 2 and 3 until the centroid stops moving, the algorithm reaches a maximum number of iterations, or is less than our epsilon, which is our threshold. Okay. This code is an implementation of the Lloyd's algorithm for clustering the data. The algorithm is an iterative method used to partition a set of data points into k clusters, where k is a predetermined number of centers. The algorithm works by starting with an initial set of k cluster centers, then assigning each data point to the cluster center it's closest to. As you can see, using clusters, using epsilon right here, our threshold. The algorithm then calculates the new cluster centers right here, by taking the mean of all the data points assigned to that cluster. This process is repeated until the cluster centers do not change significantly, or until a predetermined number of iterations has been reached, or is less than our epsilon threshold. This function includes 3 other functions, which are calculate error, cluster data, and the calculate centers. The calculate centers function takes in a data array, as you can see here, and classifications and number of centers. It calculates the new centers by taking the mean of all the data points assigned to each cluster. It returns an array of centers, new centers. As you can see, we are taking the mean of the new centers. The cluster data function takes in a data array and the centers array as inputs. It clusters the data points to the centers by finding the center that is closest to each data point. It returns an array of integers, with each entry being in range of 0 to k-1, where k is our cluster numbers, center numbers, whatever we want to call. Each entry represents the index of the closest center to the corresponding data point. As you can see, we are returning here of indexes array. The calculate error function takes in a data array and the centers array as inputs, as you can see. What we are trying to do is taking the errors. The error is the given points and the calculated points, and difference of those 2 points are called errors. It calculates the error over objective function on the provided dataset using the trained centers. It returns a single value representing the mean objective function of the centers on the provided dataset. I talked about it, but I'm going to repeat it. This function for implementing Lloyd's algorithm, it's actually mean of these 3 functions. Lloyd algorithm includes these 3 functions. It takes in a data array, number of centers, and thresholds value. Because we are convergence the threshold. It initializes the centers and then repeatedly clusters the data points to the centers and calculates the new centers until the change in the centers is less than our convergence threshold, or predetermined number of iterations has been reached. It returns the final centers, as you can see here. We are using the cluster data at here, as you can see, and calculating the centers using the clustered points. Okay, as we came to the main, as you can see, we are calling the k-means module and its functions to our main py file. As you can see, we are starting with the first question. I set k to the 10 and getting 2 centers using Lloyd's algorithm. And I'm printed those values into this file. I hope, yes. The script is first runs Lloyd's algorithm with k equals 10 and saves R in this file, in this image. And then, as you can see, we are trying to cluster our data, increasing power of 2, 2, 4, 8, 16, like this. You can see I am found suitable to store the errors in like this. As you can see here, our output of this part of code is here. As you can see, these both are almost equal, and this point can be set as elbow because our errors are not decreased by this rate. It's little rate. The error values decrease as the number of clusters increases, which suggests that the clusters are becoming more distinct and better at separating the data points. This is expected behavior, as increasing the number of clusters allows for more granular and potentially more accurate partitioning of the data. However, error values start to flatten out after a certain number of clusters, which I talked about here. Actually, elbow point might be here, but our datasets here has been declared for all. Probably the elbow is here. Okay. However, the error values start to flatten out after a certain number of clusters, as I said before, which suggests that increasing the number of clusters beyond a certain point may not significantly improve the separation of the data. This is known as elbow. in the error plot, and it's often used as a heuristic for selecting the optimal number of clusters. In this case, probably number of clusters is around 32. Maybe it can be set as 51, 55 can be above point R, which is our cluster numbers, cluster centers. Thank you for watching my video presentation. These are actually our clusters. I forget to set that, but it takes a lot of time because our data set is large. It probably takes around 3 hours to run this code. So thanks for watching my video and see you at finals.